Today we're starting Chapter 2, Section 2, which is solving two-step equations. We started out yesterday with building equations. We talked about, like in this example, we would have 2x's plus 3 equals 15. Okay, so if I built it, that would be what it would look like. Still not any different than what we did. And we talked about if you take out one of each exact color from each side, so if you have matching colors and shapes on both sides, you can get rid of them. So I have 3 blue here, which I can get rid of 3 blue here. And now yesterday we had an equation that looked like this. It would have been 2x equals a number, and we split up the remaining between those two x's. So if I take these, let's see, I have 5 in this row, 5 in this row, and 2 in this row. So I have 12 altogether, and I have to split it between those two x's. I would have each x get 6. So we would have each x have 6, if I could rearrange them here. 3, 4. Remember we split out the candies, so there's 6 there. There'd be 6 here. 2, 3, 4, 5, 6. So the answer would be x equals 6. How do we do that mathematically? We have multiplication and addition, and our goal is to get the variable alone. So let's try that again. We had 2x plus 3 equals 15. And what we did first is we took 3 away from both sides. So that's 2x equals 12. And then we divided those 2 up, or those 12 up to the 2 places. So we divided both by 2. 2 over 2 reduces to be 1. 12 over 2 reduces to be 6. And we get x equals 6. But it took us 1 step there, 2 steps there. So getting the variable alone, use your knowledge of order of operations to undo what has been done to the equation. We always want to keep them balanced, so what we do on one side we have to do on the other. We do multiplication before addition when we normally do order of operations, so we're going to undo it backwards. So to undo the problem, first undo the addition. So let's give it a try. Solve the equation for x. So here is 2x plus 3 equals 9. Here, I'm just gonna clone 3, 6. Get rid of that one. So now I have 9, 6, 7. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that one is gone. Remember, I can remove what I have from 1 on one side. I can do the same to the other side. So I'm going to take these 3 away, and at the same time, I will take 3 away from the other side to keep our equation balanced. So if I were writing the equation out, 2x plus 3 equals 9. First, I took away 3, and then we have 2x on this side, on the left side, and we have 6 on the right side. So now we have to divide our 6 into the in between, excuse me, the two x's. So when you do that, you see x equals 3. So again, we divided the 6 by 2 because I'm going to put it into the two x's. 2 divided by 2 on this side reduces to be 1. So we have x equals 6 divided by 2 is 3. So there it is mathematically, as opposed to using algebra tiles. solve this equation. This one's a little harder. If we're going to draw it out, this is a half of an x. So I'm going to draw an x with it cut in half. So half x and a half x. Actually, let's try to just do this one first mathematically. Just like before, we talked about wanting to undo addition first, undo addition or subtraction. So right now we have -4, so to undo that I want to add 4. So then I have x over 2 equals 6. And x is already divided up by 2. So that says half of an x equals 6. But I need to know what a whole x equals, so there will be 6 more down here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the whole x equals 12. If I want to do it mathematically up here, I need to get rid of divided by 2. So to undo division, I do multiplication. So I multiply both sides by 2. That cancels with that. And I would end up with x equals 6 times 2, which is 12. Solve for x. We're going to do the first one together, and then you are going to do the second one on your own. I'm going to do it without algebra tiles. First, we undo addition. And we get 3x equals 16 minus 1, which is 15. Then the second step, we have to get rid of the 3, so it's 3 times. So we want to divide by 3. And we end up with x, because that reduces to be 1, equals 5. You should do the next one before you unpause. Let's try this one again. Let's just start by writing, let's try it with algebra tiles. So I'm just going to make half of a x. And then we have -3, which is the same as adding a -3, which is what I just did, equals 5. I have to get the x or the half x by itself. So this time I'm going to have to add some 0 pairs to get rid of. Actually, I have to add 3 blue on this side to get rid of that. And I'll add 3 blue on this side. So far, that would have been, it was plus a -3. So we added a +3 to both sides. And we get 8 equals t over 2. So these are zeroed out. And now we have a half of an x equals 8. Well, I don't want to know what a half of x equals. I want to know what a whole x equals. So I need to add another half of x here and 8 more 1s. Now, whoop, I have a whole x, because 2 halves make a whole, and I have a whole x, so x equals, if you add up all my 1s, it would be 16. And here I would multiply this by 2, which is what we did on the algebra tiles too, basically, and we get 16 equals, excuse me, I said x, but I do mean t. Don't worry about this one. You are done for that part. Don't worry about that page. Here are some examples of solving the equation for x here. When we talk about x divided by 3 equals -12, we talked about that I don't know why these are all scribbled in. So these are all negatives. And so if x is divided by 3, I took an x and I divided it into 3 parts. If one part is equal to negative 12, I need a negative 12 here. And a negative 12 down here in order to figure out what a whole x is. 1, 2, 3. And you'll see a whole x, so this whole thing equals 12 plus another 12 plus another 12, which is 36. How do we do it algebraically? I need to get rid of divided by 3, so I multiply by 3. Excuse me, I said 36, negative 36. So this would be x equals negative 36 here. Here's a little different because it's x minus 7 over 3. So I'm still going to make one of those, 1x minus 7. It's divided into 3 parts, and they're equal to negative 12 again. So that means in order to be the whole thing, I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, another 12. There's 12 negatives 3 different times because I need it for all 3 of them. So now that's saying that's what x minus 7 is. So I'm going to erase this. And now that's what x minus 7 is. So now I have x minus 7 equals negative 36. And how do I draw that? There's my x. And here's my negative 7. And now we have identical things on both sides, so I'm going to get rid of 7 here, which means I can get rid of 7 here. And we have 1x equals negative 29. 12 and 12, 24, 25, 26, 27, 28, 29. Negative 29. Mathematically, if I did it, x minus 7 over 3 equals negative 12. I would multiply this whole thing by 3 and this by 3. And then these 3's cancel out because 3 over 3 is 1. So I'm left with x minus 7 equals negative 36. Then we have to add 7. And you'd get x equals negative 29. So those are really tricky with algebra tiles. So at some point, some questions are easier actually to do without them. So you should go ahead and try this one, actually those two, and report back tomorrow. All right, awesome. Thank you.